Hi, this is Pat Long here. Welcome to the second video of my SAS 9.4 performance-based exam tutorial. In this tutorial, we're going to be talking about accessing and creating data structures. We're going to introduce you to the data step if you're not already familiar with it, and we're going to look at several data step operations and some SAS procedures. So welcome to the second in a series on preparing people for SAS 9.4 based programming performance-based exam. On this video, we're going to be talking about the first topic in the performance-based exam, and that's access and create data structures. So, within access and create data structures, the first thing we're going to discuss is how to create temporary and permanent SAS data sets, and using a data step to create a SAS data set from an existing data set. So here I am in my SAS Studio session, and I have each section I'm going to go through typed in. And I retrieved these sections and subsections from the SAS website. They provide a white paper on what exactly is going to be in the SAS exam. And so you can see there's the first section, and then in subsequent videos we'll go into the other three sections. So obviously I have these three lines that I should probably comment out. So first let's look at how we might create a temporary and permanent SAS data sets. And remember that, if anything goes wrong, the log is definitely our friend in SAS Studio, and it's very intuitive. It will let us know if there's an error or a warning or even a note that may be useful. So first let's look at creating a temporary data set, and by temporary we typically mean something that exists in the work library that I have right here, which is currently empty. Okay, so we're going to start off by creating temporary and permanent SAS data sets. So what do we mean by a temporary data set? Again, that's something that exists in the work library for the session, but when we typically end the SAS session, it goes away. And permanent, we assign it to somewhere typically on a local machine where it's saved permanently, so when we come back later we can access that data set. So I'm just going to start off by creating a temporary data set out of thin air. And the good thing about SAS Studio as well, that I should point out, is that you get help. If you're familiar with a Jupyter notebook, it's very similar. So I'm just going to make a data set called My Cars that has, see again, SAS Studio is prompting us with some help as we're typing. So this data set's going to have 3 columns. Let's go model, make, and MPG highway. And this is the data line statement. And here I'm actually just typing in the data. I'm going to type in 3 rows. Buick, Regal, let's say that has 20 miles, and a GMC Yukon. run statement at the end. And so let's just we'll select all that and we'll run it. And so we didn't have any warnings in the log. Dataset worked up my cars, which has free observations and free variables, which is what I typed in. Here in SAS Studio, we get a pretty nice view of what the dataset looks like. And also you can, although I assigned in the input statement what was a character variable and what was a numerical by default was the MPG highway. So that's essentially that is a temporary data set. I'm going to show another way to make a temporary data set. And I'm going to also in this moment introduce you to the SAS help library. So the SAS help library comes with Display Manager, Enterprise Guide, and SAS Studio. So it's going to work for all three, and it just has a lot of toy data sets really. The baseball data set is one I think I'll probably use a lot in this video, and another famous data set, if I can find it, is the iris data set. So let's take a look at that. So this is Fisher's iris data set with sepal length, sepal width, and petal length. It's quite a popular toy data set. Google it if you want more information on it. But it's the measurements of 4 types of plant species. But how this relates here is if I want to make a temporary iris data set in my work library, I can actually specify work.iris, or it's more typical to just, since that's the default, have it in this manner. And so I'm accessing the SAS help library. So anytime we access a library other than work, we have to do the library reference, then a period, and then the data set we want, which is iris. And once I run this, I'll have a copy of this in my work library. So now if I go to my work library version actually open, see I have 2 data sets in there now, my cars and iris. So, but why is that useful? So when we make our work copy, we could do something like we could create a new column out of an existing column. Let's say sepal length. Let's go sepal length squared, or yeah, let's do sepal length squared equals sepal length let's try that to create an extra column. So now you see I just did sepal length times sepal length, which was, and for an instance in row 1 was 50 times 50, and now I have this sepal length squared column, which is 2500. So you can see how that may be. Didn't mean to click all that. You can see how that may be useful for someone, depending on what they're doing. If they want to do some kind of a transformation, I'm just going to comment that out. And so, if I wanted to make my one of these work library datasets permanent, best way to do that is to use a Libname statement. And this will get introduced thoroughly in the next section, but just for now, I'm going to make a Libname statement which has a library reference. I'm going to call this my lib. You can call it anything you want, up to 8 characters, no special characters. So just numbers or underscore. So I'm just going to call it mylib. And because I'm using SAS University Edition on a virtual machine, I'm actually fairly, I'm going to stick it in a specific place. And again, if your lib reference is not valid, the SAS log will be your friend and let you know right away if it didn't work. So I'm going to execute this Libname statement. And we didn't have any errors. It was successfully assigned. Let me just show you how you could have a bad Libname and what you might encounter. Let's call it bad lib. Since I haven't made any subdirectories, let's call this bad lib. It shouldn't exist. So when I execute it, we should get some kind of an error. So actually we just get no, sorry, bad lib does not exist. You'll also see in your libraries when you have data sets in there, you'll see them. So I'll comment out bad lib. And you also may find it useful if you have an existing permanent data set location, but you just want to access data from there. I should mention, and we'll get into this again later, the access equals read only option. So if I execute this statement, I wouldn't be able to write because of the access equals read only option. There's also a lot of other options for the Libname statement that aren't covered in the base SAS programming exam, but it's very useful for accessing MySQL databases or Oracle databases, but that's not covered in this exam, so I won't digress too much. But access equal read only is an important option to know about. Anyway, so I have my library. I never execute it with access equals read only. I was just demonstrating that. So let's put our work library RS dataset, the one we made up here, into mylib. And again, with our library reference, we do it this way. We put mylib period and then the dataset. Okay, and we're going to execute that. now you see in my library I have another a third copy of a dataset called Iris, and because it's the one from my work library, it has the extra column we added on called sepal length square. So okay, and then in the next section we'll move on to investigating SAS data libraries a little bit further. So in this section of the subsection of access and create data structures, we're going to talk about investigating SAS data libraries using base SAS utility procedures, namely the for now the contents procedure. So we'll also talk about using a Libname statement to assign a library reference name to a SAS library. We actually talked about that a little bit in the previous section, and we'll also investigate a library programmatically using the contents procedure. So let's jump back into SAS Studio. So back in SAS Studio, let's look at the second subsection of access and create data structures. Here we're going to investigate SAS data libraries using base SAS utility procedures. So we're going to cover again the Libname statement and using proc contents to investigate a library programmatically. So I'm just going to comment out this text. And again, earlier up here, we made a Libname statement with called mylib with the library reference, and it points to this folder called folders, my folders. Again, this is syntax. I'm using a Mac, so the syntax may not work for you. If you're in a Windows environment, you should be able to just map to a local, locally mapped drive, and then type that in as your Libname, or some subdirectory of that. So let's look at library programmatically using the contents procedure. So I'm going to actually look at the SAS help library. So if I did a proc contents, well, let me look at a data set within the SAS help library first. So if I looked at proc contents, data equals SAS help dot. We could look at the well. Let's look at another data set. Let's look at cars. So it's another toy data set in the SAS help library. And if we just hit run, so what do you get from the contents procedure? You just basically get this output that tells you sort of the number of observations, number of variables, or columns. It even gives you the permissions. You don't need to know this, for the base SAS exam, but it gives you a lot of information. But what is useful is that it gives you the type of variable, numeric or character, and gives you the length, and if there's a format or in format, which will be discussed later in these videos. It gives you that. Also lets you know if a label has been assigned to the variable. So again, let's see what the contents procedure can do as far as the library is concerned. We can add a directory option. Don't want to do it like that. You can add a directory option to the contents procedure. And when we do that, we will not only get the information on the particular data set we were interested in, we're also going to get the entire contents of the SAS help library. When they were updated, if there's a data set and a index, and it also gives you the size and when they were last modified. So this is useful information, not necessarily for the SAS help library, because these are toy data sets that are given to you, but it would be useful in a production environment if you have, you want to know more about all the, if you have 100 or so data sets you want to know a bit more detail about them, the contents procedure can be useful for that. Really on the base SAS exam, the most useful use of the of proc contents is in this instance, where you get the information about a particular data set, and you get the types, numerical, character, and the length, because this can be useful especially if you're merging data sets, which we'll come to later, to make sure that when you merge two data sets that they have the same, the cylinders, for example, when one data set is numerical and numerical also in another data set which you're joining to. So that, this is useful information for further down the data pipeline. So that's about it for the second subsection. In the next section, we're going to look more deeply into proc import and some of the ways it's easiest to access Excel files using SAS. So in the next subsection of access and create data structures, we're going to cover investigating SAS data libraries using base SAS utility procedures. So this will involve an introduction to the set statement within a data step. And then we'll also look at the import procedure to access non-SAS data sources such as Microsoft Excel. We'll also show some of the statement options with the import procedure. And I'll introduce the guessing row statement and what exactly that is in practice. Also, we'll look at using a Libname or the SAS Access XLSX engine to read Microsoft Excel files. So now we'll jump back into SAS Studio and look at these with some code. We are back in SAS Studio for the third section, or the third subsection. So first off, we're going to look at accessing SAS datasets with the set statement. We actually already did this earlier when we looked at the iris dataset, but we'll cover it again. I'm just going to comment this text out. And so let's look at another SAS help library dataset called baseball. So I'm going to make a local copy of it that I'm also going to call baseball. Or yeah, I'm going to just call it baseball to keep it simple. And so this is from the SAS help library. So we're going to do SAS help dot. Spelled that wrong. Let me fix that. SAS help dot baseball. And I'm going to introduce something here, so it's not the full data set. I'm just going to use the if statement. If team equals Cleveland. I hope that has an uppercase on the first letter, otherwise that might be a problem. But let's run that and see what the work data set looks like. So yeah, it is excellent. So we created so we use the set statement here to create a work library dataset called baseball from the SAS help from the baseball dataset and SAS help library. And we also just subsetted it for players who have a team column set to Cleveland. So now we have a work library dataset, and that's basically all you need to know about set statement use for now, at least in the base SAS program. We'll keep on using it over and over again. We have already used it a couple of times in this video. So now let's move on to the import procedure. So first, if I'm going to use the import procedure, I'm going to be importing some kind of file. I'm going to demonstrate, although this is not covered as part of the syllabus on the exam, but I'm going to introduce you to the export procedure, which will create a file which we can then import. Although I'm going to produce this programmatically here, I'm also going to post it on my GitHub page, and a link to that is in the description of this video. But it's also useful for you to know, and so you have the same Excel file that I have. So I'm just going to use the baseball data set we made in our work library. Data equals. The good thing about SAS Studio is it gives you the description of options for a procedure, so you can look here and it tells you specifies the complete path and file name of a file for the out file procedure for the option, the out file option. So I'm going to put this in a folder that I've created. This path may not work for you. If it doesn't, you should change this, and I'll put a comment to that effect. Or like I said, this Excel file will be posted on my GitHub page. And his DBMS, which is also so we're going to be using Excel, or should we use Excel less? I think Excel is what we want. Okay, again, the export procedure is not on the exam. I'm just using this to show you how to make an Excel file in the simplest way possible. And we're going to give the sheet a name too. By default, I believe it's sheet 1, but let's call it baseball. Run that. And I'm also, because it comes up in the next section, I'm going to make a .csv file that's the same, has the same data in it. I'm just going to change that where appropriate. So I think that's everything. Let's see if this runs correctly. If it doesn't, the log will let us know. There's the CSV file. And so what the export procedure and by extension the import procedure do is they simplify a data step. As you can see, it's quite an involved data step. Using the export procedure is simplified to just a few lines of code. There's some problem with the dbms equals Excel option. So if this works. Okay, yeah, so XLSX. It didn't show up in, but okay, so we made it. So we can see the .csv and .xls files, .xlsx files in our folder here. So, you know, if you didn't follow along with that, that's fine. I'll post these two files to my GitHub page along with all the code we're using here. And that's also in the description to this particular video. So let's proceed on with the import procedure. We're going to call this something else so we're not overwriting the input. Let's call it baseball import. And data file, again, great thing about SAS Studio is it tells us what the procedure options are. And the file I'm importing is called baseball.xlsx. And let me make sure I get the path correct. So I'll go ahead and copy it from here so there's no typos. And dbms is equal to xlsx. And the replace option will overwrite any existing SAS dataset of the same name. So we want that. And let's go ahead and call the sheet. Well, actually, we named the sheet on our export procedure. We named it baseball, so we want that sheet. This is useful, the sheet option, in case you have multiple sheets. Although if you don't use it, it will take the first sheet in the Excel file. So if you only have one in this instance, it would be fine without it. But we're going to put it in there. We're also going to use the get names option, so it gets the names of the columns. Get names, yes. We'll run that and take a look at what our new data set looks like. So no errors, that's good. And yeah, this looks just like the one we made in our work library that's not called baseball import, but called baseball. So that went well. Now I'm going to, first off, I'm going to do a very similar thing, but with the .csv file. And then we're going to talk about the guessing row statement. So I'm going to call this CSV. I'm also going to give this a unique name so we don't get confused. This one's going to be CSV import. And we don't need the sheet name. So I'm going to comment out the guessing rows. And then I'll explain what it is. So again, looks like it was created fine, no problems. And so let's go ahead and look at proc contents again, the procedure we introduced earlier for this particular data set. And the reason, oh, I've done something wrong. Oh, of course, yeah. Data equals, there we go. So again, another good demonstration of how the log's very useful for tipping you off to mistakes. So this is going to explain what the guessing row statement is all about. So yeah, the guessing row statement. So here you see we have various formats and end formats that were assigned by default in proc import. Pay attention to this one in particular. So if you set guessing rows to 2, it's going to base the determination of the length and the format based only on reading the first 2 rows. So I've overwritten the initial the initial data set called baseball CSV import. Now if I do the proc contents again with the guessing rows option in there, you'll see different results here. Like position was a length 2, now it's a length 1. So this is a bit silly example. You probably wouldn't do guessing rows based only on 2 rows. But you might feel like you could get a good approximation of the length of a variable based on 20 rows, depending on the size of your data set. So it's just a useful option to know about, and it's mentioned in the syllabus, which is why I bring it up. So I'm going to move this above. And now we're going to look at how we might use a Libname statement. And again, I'll use the baseball file we made. I'm going to call this my XLSX. And let me just make sure I get the right location. So yeah, it's a Libname statement, and let's just make sure there are no errors. So good, we got the library, and there it is. And then we have the same data set. So this is what's meant by using SAS XLSX engine to read a Microsoft Excel .xlsx file. So we covered a lot in there. But again, this full .sas file, I'll save it, and it's going to be available in the description below and on my GitHub page. So next we're going to talk about combining SAS datasets. So in this next section we're going to talk about combining SAS datasets. We're going to cover 3 ways that this will be accomplished for different circumstances: concatenating datasets, merging datasets on a one-to-one basis, and merging datasets one-to-many. So let's jump back into SAS Studio and look at some code. First off, let's concatenate 2 datasets. Just going to comment those lines out. And I'm going to call this work library dataset called concat. And we use the set statement, which we've seen several times. And we're just going to take 2 different SAS sets and put them together. They have to have matching columns. So I'm going to use SAS help library datasets. Let's use Iris. And I'm going to introduce a subset of the Iris dataset. Let me just look at it to make sure I know what its column names are. So yeah, let's do where species equals Setosa. And then so this is one data set, which is a subset of the SAS help Iris dataset. And if we're going to concatenate 2 data sets, we're going to also need one with matching columns. So let's take another subset, the Iris dataset. And this time we'll take where equal species equals versa color. And we'll run that. So basically we're taking the first subset of the Iris dataset, and we're appending this on the end of it, the second subset of the Iris dataset. So the log is our friend as always, and it will explain this to us, assuming there's no errors, which there are. Oh, yep, I did miss an equals, so there we go. So yeah, oh, I think I got the names wrong. So this is good to you get to see me troubleshoot. I think it may be a case issue. Let's go look at the data set in the SAS help library. I think chances are I probably just used the wrong case. Yeah, I did. So I used lowercase instead of uppercase for the first letter. So let's fix that. I didn't have an error, but I had to empty. I was appending one empty data set to another empty data set, so that didn't work. So here we go, and we have 100. It's a 200 row data set, and we have 100 because there's 4 species, and we put one of them on top of the other. And the log tells us that we took 50 observations read from SAS help.iris, where the species was equal Setosa, and then we took 50 more observations where the species was equal versicolor, and we created this work data set called concat, which are appended one on top of the other. So that's basically all you need to know for a concatenation of two data sets. They do have to have matching columns. So for the merging of two data sets, we're going to look at two. Again, we're going to look in the SAS help library, and we're going to look at two different data sets. So first off, let's look at SAS help.by, and you see several dates in here and an amount column. And now let's look at the SAS help.count series data set. Again, you see some dates. So I'm going to do a one-to-one merge on the date column of these two different data sets. So instead of using the set statement, which we've used in the concatenation example, we're going to use the merge statement. And then I'm going to put in the two data sets. And the second one is called count series. And I'm using the in option, n equals b, and you'll see why. So we're merging by a particular column. Like I said beforehand, they have the date column in common. This is something you tend to have to be careful with. In this example, you don't, because they're both SAS dates, but you need to make sure on a merge that they're the same data types. You can't typically merge a character and a numerical variable. So just be cautious. And proc contents is your friend in terms of knowing what's in your data set. So here I'm saying I'm doing a one-to-one merge. So I'm saying if a date is in A and that same date is in B, then I want them in my output data set, which is called one-to-one. So let's see what that looks like. And so we get an output data set with just 3 rows in it. So we have the amount from the SAS help.by data set, and units from the count series. So this doesn't seem very meaningful, but maybe it is. Maybe you're joining two different data sets, and you just want these 3 rows that they have in common. So looking at the log, here you see, we read 11 observations from SAS help.by and 108 from SAS help.count series, and they had 3 dates in common, and that's how we did the one-to-one merge. So now let's look at some one-to-many let's look at one-to-many merge. So I'm just going to copy this data step. I need to comment this out. Okay, so I'm going to copy this and I'm going to call it one-to-many. I'm going to take away the restriction of B. Maybe I want all 11 rows of my one-to-many data set to have a missing value if there is no valid date from the count series data set. So here I'm just restricting it on the first table, SAS help.by. And so here, like I mentioned, we've got several missing values. And so that's an example of a one-to-many merge. Again, some key things here, using the in option and restricting it based on whether you want a one-to-one or a one-to-many merge. In SAS, you typically have to sort your data set when you do a merge. It's generally considered best practice, and it's often useful to help the merge. And we'll talk about sorting values in a section further, actually in the next section after this section, which is access and create data structures. In the second section in the syllabus, we'll be talking about the sort procedure. But for now, we've given an example of how you can concatenate data sets, how you merge data sets one-to-one, and how you merge data sets one-to-many. Next, we'll talk about date values. So now we're going to talk about creating and manipulating SAS date values. Here we're going to explain how SAS stores date and time values. We're going to use SAS in formats to read common date and time expressions, and use SAS date and time formats to specify how the values are displayed. I'm going to try and explain how to create and manipulate SAS date values and all the three subpoints below that using one data step. So we're going to look at SAS help library data set called air that has dates in it. And let me get started on. I'm going to make a work data set called simply air. Take that from SAS help.air. And first off, I'm going to make a column called date 0. Let me call it date 0. And it's simply going to be the date times by 1. So in this column, I'm going to show you the numerical representation of what a SAS date looks like. And then I'm going to introduce some functions to show you the day function. It's a number from representing the day of the month that's obtained from a date. And then similarly, there's a month and a year function too, which give us the same information for the month and the year from the date column. And the year function. And then I'm just going to add a column arbitrarily that's from the time function to show you what date times look like. This isn't in the data set. So this is just going to take the current time when you run it. So you may have a different result to me. And then I'm going to make a date time column. Oh, that won't work. I'm going to make a date time column using the DHNS function, which has 4 arguments. You see typically the built-in SAS functions, the first one's over exposes to in the string, only take 1 argument. This one's going to take 4, which is going to be the day, hour, minutes, and seconds. Okay, I'm just going to make it 0 for everything except the date. And then I'm also going to introduce what's mentioned up here, formats and formats. I'm going to format our date time, the column we just made, the last column we made here. I'm going to format it using a format statement and using date time 20. And this is how you execute format statement in your data set. You type format and then the column, and then you have to use one of the date time formats. There's a number of them that you can search for on Google or in SAS documentation. You'll get all the different types of formats, but for this one I'm just using date time 20, and we'll see what that looks like when after I run this. Oh, sorry, I didn't put a set statement, so that's not going to work. So again, the logs are our friend when we make mistakes like that. So great, so here you see, I'm going to run you through each of these columns. So this was just a 2-column data set, you can see from the log. And then I've added on 6 additional columns. So first, date 0, this is where I just multiplied the date, which is January 1st, 1949, by 1. And we get a numerical representation of negative 4017. And the reason is SAS dates are a number starting with January 1st, 1960 as 0. And so here we've got, before January 1st, 1960. And so as we go up, we get closer to 0. Next, I did the date. Well, these were all the first day of the month, so we get 1 for each one, and then the month, 1 through 12, and so on. And the year, as we'd expect. And here we had a time representation, numerical representation of the time, which we didn't actually use, but here you saw I used the date, and then I used midnight 000 for the hours, minutes, and seconds. And also this is the important to note. This is the date time 20 format. So you could use different formats. I think date time 18 chops off the seconds. Don't necessarily need to know that, but you do have a lot of options for formatting the representation of the date time column. So we pretty much covered everything regarding SAS date values. We've explained how SAS stores date and time values. Should just note that An in format is a specification for how a raw data is read in, and a format is a layout specification for how a variable or a column uh, should be printed or displayed. And we used a format here, but if we were reading in raw data, we might be using an in format to interpret, what something like a daytime 20 format means. So that's it for the section on creating and manipulating SAS date values. Next, we're going to look at subsetting a data set and controlling which observations and variables we might keep in a SAS data set. So and this will be the final section for this video coming up. So we're on to the final section of access and create data structures. In this section, we'll look at controlling which outputs and variables in a SAS data set are to be processed and output. We'll introduce the where statement in the data step to select observations to be processed. We're also going to subset variables using the drop and keep statements. We're going to use something different, also called drop and keep, the data set options that specify the columns to be processed and or output. So let's jump back into SAS Studio and go through the code. We're going to look at using the where statement in a data step to select observations to be processed. So let's look at the SAS help library data set that we've been using a lot, called Iris. I'm going to overwrite our existing work library data set called Iris. I'm going to show you the where statement in action. So set from the SAS help library again, Iris, and here's the where statement. Again, the great thing about SAS Studio is it gives us these prompts that tell us about the syntax and give us extra information. So here I'm going to use the species column equal to Setosa. I spelled that right. And input in the run statement, and I'm just going to select this and run it. If I did anything wrong, we should know in the log. Perfect. It looks like we have 50 rows and 5 columns, and the log gives us the details. There were 50 observations read from the dataset SAS help.iris where species equals Setosa. And you could do this for any particular column. You could do a subset based on a numerical value being greater than something. I just chose to use a string because it's fairly straightforward. So yeah, that's about it for the where statement for the base SAS exam. Now let's look at subsetting variables to be output using the drop and keep statements. So let's go back to our baseball data set, and we'll just explore the drop and keep statements in that one. So SAS help.baseball. So let's look at what it looks like if we just keep two particular columns, name and log salary. I think I've spelled that right. Name and log salary. Again, if I made any typos, the log will let me know for sure. So using the keep statement, there's 23 variables in the baseball data set. not sure off the top of my head, but in using the keep statement in this way, we're just keeping two of those variables. So let's look at what the log tells us. Well, and we see in the output data set we have 322 rows and 2 columns, which is what we wanted. And so let me comment this out. And instead of using the keep statement, let's do what we just did using the drop statement. So it's basically the opposite. So we'll be overwriting the 2-column data set we just made. And so now we have 22 columns, you know, because we just dropped the log salary and the name. So you just have all these other columns. And so yeah, that's about all there is to the drop and keep statements. Now, the final bullet here is to use the drop and keep dataset options. And there's several dataset options. I think these are the first ones we've used in this video. And then the first ones explicitly talked about by SAS for the base SAS certification study guide. So let's use the drop and keep dataset options with the same dataset, baseball again. So if I was doing, and let me show you actually how you could use both of them. So if I was using keep, let's use name and log salary. And hits and at bat. I think it's, yeah, spelled that right. But then let's drop. But then we could also, you can use them together. It doesn't necessarily make sense to use them together, but let's use them together to illustrate how they work again. The log is our friend, and I shouldn't have done. This should be in the set statement. So let's start with baseball. Okay, so that's my work library data set. I kind of did this backwards, sorry. SAS help.baseball. And there's the run statement. Okay, so let me explain that again. So this is the keep dataset option. We're keeping these 4 columns, but then we're going to drop log salary. So we should end up with 3. And another great thing about the log is it's going to tell us if you know, if a column doesn't exist, it will point out an error, or I think it'll point out an error if I select a column to drop or keep that doesn't exist. So yeah, let's look at this. Okay, and that's exactly what we wanted. Then we can look at the log for a bit more interpretation. Yeah, so I said keep all these, but then I also said drop log salary, so we ended up with name and hits and at bat. And it's a bit of a silly example of how you might use both of them together. Probably be the more realistic or sensible way would be that you're only going to use keep or only going to use drop, but you can use both. And yeah, so that concludes everything for this section of the SAS base exam. this entire .sas file that I've been using is linked in the column below on my GitHub. Linked in the description below in my GitHub page. Feel free to leave any comments, or if you find any mistakes, I will run this one more time before I put it on GitHub and put it in the description of the video below. So, yeah, thanks very much for watching, and follow on to the next video in section 2, where we'll be talking about managing data.